All right, here's 7-2 day 2. Not a real long lesson by any means. We're still solving. We're still mostly using elimination. Though I'm going to throw you a little curveball. In the last one, I'm actually going to jump back in the very last problem and actually do a little bit of a substitution, because I think it's a case where you could get suckered into doing elimination. But that's going to be a thing when we're solving now after these two sections that, most problems from here on out, they're not going to tell you which technique to use. Make your pick, right? You can use either one, but sometimes one method is easier than the other. What I want you to see on this one is we've got some coefficients that are not great. And a lot of times this can come up if you have data that involves percentages. Like the 0.02 might involve like a 2% of something. So what I'm going to do, because if I'm doing elimination, decimals are not ideal. All right, and if I can get rid of them, I want to. So I notice with this first one, okay, I would prefer 2x minus 5y equals negative 38. And for the second one, I'll take 3x plus 4y equals 104. All right. So basically, each one of those coefficients, I move the decimal twice, which is the equivalent of multiplying by 100. Okay, and we've seen that in day 1, that if you want to take one of your equations and multiply it by any constant, well, you're free to do that. That's not going to change your solutions or anything. Now, we're not out of the woods yet, because notice if we were to add up these two equations, it's still not going to work great, because a variable is not going to get eliminated, but we're getting there. And I'm looking at these x's, right? And I'm thinking if I go negative 3 here and 2 there, this should work out quite well, and everything is going to differ only in sign, and things will be good. Okay, so on my top one, that would give me negative 6x plus 15y equals 114. And then down on the bottom, I would get 6x plus 8y equals 208. All right, and now this looks really good, where I can add those. My x's get eliminated. I have 23y equals 322. Okay, the numbers are getting a little bit bigger, but they're whole numbers, which is good. That's going to make life a little more doable when solving these. Divide both sides by 23, and I will get that y is 14. Okay, y is 14. One other thing that I like with that one compared to day 1 is I think when I was eliminating variables in day 1, this is just kind of the way it worked out. You can always eliminate either one, but I think I eliminated y every single time just because that was the most efficient way to do it. So you can certainly see here, you can eliminate x. That might be the most appropriate thing to do. Let's go back to here. We go back to one of these two original equations, now equipped with some valuable information here in terms of solving, which is that y we know is 14, and that's a game changer. This would mean that 3x plus 56 is 104. Subtract 56, and we get that 3x is 48. divide by 3, and there we have it. X is 16. Okay? So I wanted to throw that one in because that's kind of a worst case scenario in terms of like coefficients. Look at what we started with. We didn't have much, right? But you could have a word problem that just doesn't give you super nice coefficients. And that's a good look as to how you would handle that. All right, so here, this is an interesting one. Okay, this problem you'll see has a lot going on. But we'll eventually get it set up and we'll solve with elimination. All right, there's some information I would have to give you right off the bat. Like right away I would tell you on this one with the variables. Let's say x is the speed of the plane and y is the speed of the wind. Okay, these are the two things that we want to find, so don't lose sight of the fact that that's what we're after. We want to solve a system of two equations with two variables. Okay, now this might be another thing that I would give you to get you started. X plus y is going to be the speed with the wind. X minus y is going to be our speed against the wind. Okay, that's going to give us our two equations. So we need a couple speeds here that we'll need to figure out. Okay, one other thing, and I'm trying to give you a lot of this stuff now because number 43, I believe it is, in your homework assignment is really similar to this one. So this is one to pay special attention to because the one in the homework doesn't give you all this stuff, but I would want you to have it because if you had a test question like this, I would give you some of this info. The last thing that I would tell you is that distance is rate times time. Okay? Distance is rate times time. I'm going to use all this information to get my equation set up. All right? So I've got my two variables. Speed of the plane, speed of the wind, that's what I'm after. And I have two different scenarios to set up my two equations. Okay? Speed with the wind and speed against. So the distance for both of these is, because now the two equations I'm going to write to actually solve is really going to be based off of that. Okay? Here's how I'd set them up. The distance is fixed for this trip from Salt Lake City to Chicopee, I think, somewhere in Massachusetts. Okay? It's 2,000 miles. So here's equation number 1, that 2,000, okay, now I'm going to say x plus y. Okay, that's a speed. Right, the speed of the plane with the wind. So now what I need is how much time went by on the flight with the wind. Well, it tells us that it was 4 hours. Equation number 2, this is really the trip against the wind. So this is going to be x minus y. All right. And that took 4.4. Okay, now you might be thinking, where on earth did you get that took 4.4 hours? Well, it tells you it took 4 hours and 24 minutes. Okay, if you did 24 divided by 60, basically converting minutes to hours, you would get 0.4. Okay, so it took longer against the wind. Now, my technique is going to be elimination, but I have two equations with two variables to solve, okay, which is exactly what I'm looking for. All right, now this one's really going to clean up on the top because I'm actually just going to divide both sides by 4, and this one with the wind is going to become 500 equals x plus y, okay? And that's going to work out quite nice, okay? So now the second one's going to be a little bit more work here, that I'll have 2,000, and I'm going to distribute the 4.4. Now we kind of just got done looking at this, that those coefficients are not all that nice, okay? And this would be something that would be pretty darn tricky to do. And so I think the one in the homework gives you a little bit better numbers to work with. Okay. But basically now what I wanted, it's kind of like that one before that I've got these decimal coefficients and I would like them to be whole numbers. Okay. 4.4 is a tricky little number to work with. What would you multiply 4.4 by to get a whole number as a coefficient? Okay. Turns out the ideal number is to multiply by 2.5. But if you were to take this and multiply by 2.5, it's going to work out really well. Okay? That would give you a constant over here of 5,000, 11x minus 11y. Okay? These steps are getting to be a little bit tricky. But what I'm trying to do is to get myself some coefficients that have whole numbers that aren't so bad to work with. Okay? Now we're getting close where we're going to actually do some elimination. Because the two equations that I'm really focused on right now are right here and right here. All right. Now this, I think, is much easier to see, is that I want to take this one, and multiply by 11. And then things are going to be set up really, really well in order to eliminate a variable. Okay, after we do that, what we'll have is our equation for with the wind will be 5,500, which will equal 11x plus 11y. I'm not going to do anything to the one into the wind because I already like the way that one is set up. Because if you'll notice at this point, if I add these two equations, we are in great position to go ahead and eliminate y. So that's gone. The constants are 10,500, and then I get 22x. If you divide both sides of that by 22, you will get 477.27. Slipping down into my next example here. But that's an answer. Okay, that right there, that's the speed of our plane. It's going 477.27 miles an hour. Okay, and now as far as which equation to go back to, I definitely want to go right here. To get the wind speed, that's going to be easily the easiest. As I'll say 500 equals 477.27 plus y. Subtract 477.27 from both sides, and you get that your wind speed is almost 23 miles an hour. Okay, so most of the work there isn't necessarily in the elimination part, but I had the variable set up for you and gave you the distance as rate times time, but just getting those equations, one for with the wind and one against the wind, and I think that concept is easy enough. Where this one gets a little bit tricky is to work with the equations so that you get some coefficients where you can eliminate a variable. Okay, that's always a big thing with elimination. This one does not even have close to the number of steps to solve, but I want you to see it because it's kind of a sneaky one. Basically, we have a supply and a demand function. Okay, this is an economics example. And we're trying to find like this equilibrium point, which is basically kind of this point that would give you, based for the company, based on what you're able to produce and the demand that your market has for it, as to how much of your good you should produce, and then the market value of the good. In other words, what you should sell it for. Okay, it's not a terrible one to solve, but I want you to see here is sometimes after doing all this elimination, right, you see that those x variables are lined up And you're like, okay, let's eliminate these two. But this is what I want you to watch out for. If they both equal the same variable, and this is technically substitution, this is your much better option, is to then take the two equations and set them equal to each other. Okay, X is how many of the good that we should produce. It's some type of digital device. Who knows? Like it says a digital assistant, a phone or whatever. I don't know. Doesn't really matter for the steps to solve. Okay, so here what I do is get my constants over on this side by subtracting 60. My x terms on the other side by adding 0.00001. Okay, and those would be over here. And then I would divide both sides by 0.00003. And that would give me the first part of my solution, which is that we should plan on producing 3 million of this product, okay, based on what we can make and based on the demand for it. In other words, how many we could expect to sell. Okay, now the P is the price. Okay, based on how many we made, that would dictate what price we should ask for these. I'm going to go back up to here and say 60 plus 0.00002. I need to plug in 3 million. Now this is kind of nice because I'm getting P, but once I had X, I actually don't have to solve anymore. This just needs to get plugged into a calculator to get your value for P, which is your price, which would be $120. Okay. We've seen one like this before where you really just need to set the two equations equal to each other. But after doing all this work in elimination, I wanted to give you a reminder that if you have one like this, substitution is the best approach to take.